All right, this is Mr. Hayden. This is chemistry week 9. So obviously, want to make sure that we're about halfway through the semester or so. So again, remember, we want to make sure that we focus on a few things. One is maintaining your grade at a certain level. That's important. Also, you guys need to make sure that your science notebook is put together and progressing. If it's not, you really need to start working on that. You do have a spring break, aka Mr. Hayden's birthday's week off. This district recognized my birthday even before I was born, and they gave the whole week off for it. That was really nice of them. And so you have that week as well to get caught up. So you need to make sure you make that commitment. It's worth 100 points. You have a chance to get over 100 points. Some people even got about 115 points because it was just amazing, and so I had to give additional credit for that. So keep that in mind as you do it, that if you're a minimalist, then you're going to receive a minimalist grade. If you're a maximist, then you're going to receive a better grade than you think, and that's how you get extra credit in this course. So what we're going to do again, we're going to talk about acids and bases. Now, more of which we're going to look at some various ones, but really an acid is anything with a positive H ion inside or in a solution, whatever we're talking about. We're going to talk about the solution being in water a lot of the time, but also in general. And then for bases, it's an OH negative. And what happens is, as you put both of them together, okay, I'm just kidding, I'm trying not to write apparently, H2O, what happens when they come together? Then what happens when a positive, say positive 1 is added to a negative 1, what happens? What is the resulting number? Positive 1 and negative 1. Help me out here. 0, which means neutral. Very good. Very good. Okay, so basically what we're talking about is the pH level or the ion content. If it's completely, like, is it fully acidic where no molecules are hooked up to each other and there's a bunch of free ions, free hydrogen ions, or vice versa, and we'll see that in this PowerPoint. All right. Okay, so for the essential question, listen. The essential question for this is basically, give me an understanding of, say, your saliva in your mouth. Give me what the pH level of your mouth is, if it's acidic or if it's base, and tell me what are things that can really affect the saliva in your mouth. For example, what could you put in your mouth? A couple examples that could change the acidity or change it to be more of a base. Okay? Oh, let me go back. I apologize. I was talking as I was doing this. All right, so acids and bases are broken down basically into electrolytes. These electrolytes, specifically in water, it depends if it's acidic. If it's acidic, it has it can burn you and all that stuff, but what it really does is it has a lot of hydrogen ions, H pluses. And if it's a base or basic or alkaline, you'll see some of those alkaline waters out there. Have you seen those things? You see, you'll look at it, say alkaline water, pH of 8.5, and we'll go over what that means. But it basically means that it's trying to put water into your body that is actually alkaline. They say that cancer cannot grow in an alkaline state, and so it's only grown in an acidic type environment. So if you can take your body and you can change it to be more more basic or more alkaline, you can actually, in theory, help reduce the concept of having the issue of getting cancer and things like that, because it can't survive if your body's maintaining a level of neutral or alkaline. So that's important. We're basically going to look at how to look at some of these acids and bases or some of these solutions together, and we're going to see how they break apart and make either a base or make an acid. We're going to see that. As soon as I figure out how to click. There we go. Okay. Arrhenius or acids. Basically, this gentleman first proposed the theory of ionization, or this idea of acids and bases, and identified acids as a substance that are ionized in water, and that's the big part right here, water. This gentleman figured out in water very specifically. Are you laughing because it's not a guy? I'm just messing it up. Is that it's in water. And most of the time when we look at the other ones, like you'll see some other people's ideas, they were in other solutions, because there's other solutions out there other than just water. Okay, but this very specifically spoke of water. So what happened is they took with a hydrochloride and water, and what happened is that H ions don't really just like float around. Basically, it's called hydronium, and it's this right here. This is an H positive. Okay, you see it's H3O. That's weird. H2O is normal. You notice that? H3O is weird. The additional, what happened was this hydrogen had a single displacement, got added to the hydrogen and became H3O. And then this one right here, since this is a positive and this is a negative, let me go back and let me clear the page. Okay, so if this is a positive, oh, come on, Turbo. Oh, just kidding. Let me go ahead and go back to my writer. So this is a positive and this is a negative. But as this positive one got brought over here to this neutral element, or neutral molecule, which is oxygen, or sorry, water, you get this little positive right there. Well, if I just took that positive away from the chloride, what happened then? What happened to it? What happened? Where'd it go? It's like my son would say, where'd it go? This little Cl negative, basically nothing happens to it. It's just left to pasture, just left out there. There's another ion to hook up to something else. Maybe sodium. You can make sodium chloride, which is a salt. You look excited, Jordan. And now you're on the YouTube, Jordan. Tired? That 1 hour? The 1 hour just really messed me up. All right, so again, H3O, or AKA hydrogen ion, is what we're used to seeing when you talk about acids. So this hydronium ion is also known as a hydrogen ion. Basically allows for some of the shortening of this stuff. So example, if you look right here at Cl, basically you add it to water, which is assumed, you get H3O, which is technically just a hydrogen ion, and this look on. This is a shorthand version right here of the equation above. It's just a shorthand. It's now assumed that H3O is just a hydrogen plus. It's just assumed because it's in water. Okay, it's in water, so that kind of goes away. It's just a shorthand for the exact same thing. So the idea, though, is that hydrogen plus ions do not exist in water solutions, but are attached to water molecules of hydronium. Again, there's not just these hydrogen pluses hanging around, but when you want to start like getting hydrogen to get away from off the water, it's pretty easy to do that because the water wants to be neutral. It's like, dude, seriously, hydrogen, just get away from me. Like, you're not in the family anymore. Then kicks them out. Three's a crowd. Four's a crowd. Okay, so on the opposite side, looking at bases. Same thing with water. Looking at sodium hydroxide, you can break it down, and what happens is this is a positive one, and this is a negative OH. And by the way, hopefully I don't have to review how those positive and negatives got there, but it's basically, if you look at the periodic table, and you have the cations to the left, and you have your anions to the right, where does it fall on the column? Okay, that's very important. Does that make any sense? Hopefully. Okay, if you don't understand that, please review that, okay? Please, it's like last semester, so let's Google it or something. All right, so it basically breaks it down into two different ions. A positive ion for sodium, which, hey, guess what? If I have chloride left over for the acid, and I mix it with a base, guess what I get? Because remember on the last one, I'm just going to throw this out there to you so you get all crazy on this. Look at this. Chloride and hydrogen. So if I added hydrogen to this, if I can, because that's how I roll, and I add a chlorine to this side, what happens? What does that mean? What does those equal to? I have an H, and an O. Jordan, thank you for waking up and saying water. I think she was thirsty. She woke up and she's like, water, water, but whatever, that's still right. Okay, so you got H2O. Perfect. And then what is NaCl? She woke up again. What's salt now, it sounds like. He's like, salt, I need salt and water. Not together. Okay, so that's right. And this is the thing. When you take acids and bases and you put them together and you call neutralizing them, you're going to get water and you're going to get a salt. Now, it may not be sodium chloride in the salt, but there's like other salts out like potassium chloride and all these other things that are considered salts. Okay? So that's all you get. And it neutralizes them. So properties of acids. That all acids have the same type of properties is that they basically, they will neutralize bases. Acids will neutralize bases and form a salt and water. They have a sour taste in your mouth. That's why if you ever had, anyone ever had a lemon before? It's these really weird things that grow on this tree, and they're yellow.
Wow.
It's amazing. I know, but there's sometimes greens that are limes, but we're not going to get into limes because there's this crazy thing where there could be both sometimes. And the lemon, that salt, that sour taste in your mouth is an acidic taste. It means that in its body of juice, that it actually has H3O in it, or hydrogen. It's an acid. You can use it to clean things. Like you can actually use lemon and like rub it on like, I don't know, I think you can like buff a tire or a tire rim with it or something like that. And it will clean it because it will bring it the acid will actually break it down. It reacts with metals, again, to make salt and hydrogen. Now, remember, don't get screwed up on metals as being like a shiny piece of thing that you can like, you know, chrome out your car with, okay? Which we know Jordan from No, not so much. I thought maybe this time you know. It's other things like sodium, chloride, not sodium, potassium, all these things on the left side of the periodic table. A lot of them are some metals, and then there's some transitional metals in that little weird box to the right. That's the diagram. Now, I think it's important. The pH level is less than 7. So if you have a scale between 0 and I believe it's 14, 7 is the middle. You're going to see this later. These are all acids. And we'll see that these are all bases. You guys are awake here, huh? It's not going to make everyone do jumping jacks. I'm glad that we're doing sitting jumping jacks. Too lazy? Alright, so let's get back into this. Let's go. Now I think we can go a little, hopefully as soon as we get past this, we can start going a little bit faster. Oh, okay. Give me a second, guys. I have to get my... There we go. All right. So now bases are kind of literally the opposite. If acids neutralize bases, then what do you think bases neutralize? Now say it again. Follow me. If acids neutralize bases, what do you think bases neutralize? Hey! Acids! And guess what? It actually set it up on there. I just was totally tricking you. Right there. Very good. Very good. All right, so we know that. Good for us. It has a bitter taste in your mouth. So like, you know, you had unsweetened chocolate. I'll go with that example that's on the board. That's funny, I was like. We're going to go with unsweetened chocolate. We're not going to go with this one as an option because hopefully you don't know that heroin has a bitter taste. Okie dokie. Back to this. Also, very slippery. All right? And so it reacts with fats and oils to form like soap. By the way, a lot of your soaps, it's a base, okay? That's why it cleans you and things like that. Helps remove acid type stuff from your body. The pH level is greater than 7. Okay, so 7 is neutral, greater than 7. So far, so good? No, your essential question is the one where I said your essential question is this, and I said what it was. Remember, essential question for the repeating, so people just said, I was saying listen because I was saying what the essential question was. Hopefully your mic, your headphones are on. But I was saying, talk about what the acid level is inside your saliva and what things you can add to your saliva to either raise the level of acidity or to reduce the acidity level of your saliva during that time. Salts. So again, let's just break this down what salt actually means. Again, when it breaks down of hydrogen and of acids and bases, it's going to create these. So example, here's a salt here in the solid form, S form. That's why the S is there. Make sense? Everyone know that? What's going to happen is you're going to get a break right there, and they're going to become two different ions. You're going to have your positive cation and your negative anion, and then you'll have both of these as ions in an aqueous solution. Basically like a water, something like that. Make sense? Make you run a mile. Wake up. Same thing here. It's the exact same thing when you take the potassium out. Becomes positive in aqueous solution, and there's that nitrogen like nitrogen oxide aqueous solution. Same thing here, it breaks here. Instead of it being written down like this, that does not happen. Since it's an ion, there's just two of them. Okay, they're not connected, there's two of them floating free. So this 2 gets moved up here and becomes a positive lithium ion. That's where batteries come in, lithium ion batteries. You have any idea what I'm talking about? No? Just keep going? Got it. Perfect. And again, aqueous solution, aqueous solution. What are you guys noticing on the right side of the product? What are they all? What kind of solutions are they? Help me out here, guys. Who said it? Say it louder. What? What? Aqueous solution. Very good. Correct. Mondo. All right. All right, so again, general properties, again, something like this. You don't have to really know this. You don't have to really know this. This is if you're doing this thing. We're not doing that. You want to know it reacts with bases. We want to know this one reacts with acids. This one feels slippery. This one reacts with metals. And really crossed it out, but these are important. It tastes bitter or tastes sour based on what we're looking at. Just so you know, I'm going to start moving a little faster now because these are kind of like things you already know. Again, these are definitions of how people define this acid and base thing. So example, only in water, Arrhenius said it produces these right here. It produces them, inside the solution. Bronsted-Lowry says that it actually will donate or accept H positives. Very much the exact same kind of concept. It's just two different people, two different time periods, both without lives at all, trying to figure this out. Okay, so we just take it for what it is. And then the Lewis one uses organic, and instead of a hydrogen, they're saying an electron, so the electron movement. And again, this is important when it talks about like hydrogen movements across like your body and things like that. So one that we're going to mostly look at is going to be the positive, H positive, and the OH negative. That's going to be more of what we're looking at. So let's look at this. This is an example of how each one of these are written. For each one of these, the only thing you'll notice is that right here, the Lewis one has like these weird dots right there. So to make sure that if you ever see the dot next to it, it's the Lewis model. Really don't need to get out of this, guys. But again, we already know this. The hydrogen in an aqueous solution, if we have H2O, what will this become? H2O and I added hydrogen. What is that? H3O. Did anyone remember what the name of that was? No? Hydronium? Hydronium? You're about to look it up on the Google. Selfie. Okay, same thing here. This is the concept of coming together, is that this right here can come together to here. Trying to think. If this loses a hydrogen positive, it becomes the stable NH3. The exact same thing here is if this H kind of goes away because it becomes a transfer of hydrogen into something else, it becomes a new type of ion, NO3, and this negative here means it can accept another hydrogen. And just so you know, if it's 2 negative, so let's say it's 2 negative on the top right-hand corner of that molecule, then it can accept 2 hydrogens. Because 1 positive hydrogen as well. thing. This one is a double displacement. Yep. Oh, it just says it on the page. Good. I wasn't even looking at that. And basically the hydrogen here wants to come over and become, hook up with those guys. And then the salt wants to come over and create, or the sodium wants to come over and create salt and water. So that's neutralization, which we already talked about. Same thing. Neutralization is a pH of 7. Now this actually is relatively important, is that right now when you look at this, it depends on how many hydrogens are actually floating around and how acidic it is. So in this case, this right here is not as acidic, but this one's going to be stronger. So this right here is a strong acid because look at, if you look at this, almost none of these, or there's 100% disassociation. No one wants to hang out with each other. You know what that's like, right? Okay. No one wants to hang out with each other. Everyone's in an aqueous solution saying, yo, I don't want to hang out with you, seriously, go away. So there's a bunch of hydrogens and a bunch of A's, and they're just separated. Strong, very strong acids. Then you get partial ones, where you'll see that some are still hooked up with each other. Okay? And some of these are free-floating. It just means that there's partial disassociation. There's some people hanging out with each other, some people don't hang out with each other. It's okay, George. It's okay. Sure. One of these days. And then we have a weak acid where there's maybe a couple, like you can see there's just a few of these bad boys floating around, but not extremely acidic. That's the difference. Is it completely disassociated, or is it partially associated? Or is it just very weak? And a lot of this one right here, you can see this little back and forth. They're just jumping around like, yo, what's up? Want to hang out? Cool. No, you're not cool. Go away. Okay, I'm not going to hang out with you anymore. You know those people at the parties. They just walk around, they're like group to group, and they're like, yeah, cool, yeah. But you should go over there and talk to them. They would really want to talk to you all day. They're like, oh yeah, cool, and then they go do that. That's back. This type of solution. Okay, so again, strong bases. Whoa, don't know what that was, so I'm going to go ahead and clear that. Strong bases, again, what? 100% dissociation. Weak bases are partially. We good? We good? This is the pH scale for the people who've never seen this before. We have 2, which is over here, and 12 is over here. Technically it goes from 0 to 14, but most of the stuff falls within the 2 to 12 range. So let's look at a few of them. Normal rain. Go outside, there's rain. Look at the pH. Is that basic or acidic? Help me out here, guys. This is not hard. Neutral. This is neutral. If it's on that side of it, on the left side, it's acid. On the right side, it's a base. Right there where it says normal rain with an arrow. Is it an acid or base? Very good. Okay, normal rain, because of the stuff in the sky, is actually acid. Now there's acid rain, which is even worse, but that's what it is. It's very acidic. Neutral, again, is right at the middle. Fish populations drop off at pH that's less than 5. So that's actually something important, that if we completely start screwing up the ocean and start putting more stuff in there, which we do, it raises the pH level of the whole ocean eventually. And eventually they all die and then we die. So not a big deal. I like to live, so I'm going to say that's probably not cool. Just going to say. Another one here, and these right here are natural water pH. Typically, without all the stuff that we put in it, natural, pure, clean, fresh water could range right around neutral right now, but people have been using now creating alkaline water, basically forcing OH negatives into it to basically raise into more of a base so you can drink that. It's more expensive, but you can definitely, you can buy it. Like if you go to Trader Joe's, they have like a whole section of like, these are your normal drinks and these are your like hippie drinks. I mean, drinks that are very good for you, you pay extra money for, that probably are no different than anything else you drink. Okay, here's the pH of rainwater, just in general. You are here, approximately. I was probably off by 1 or 2 meters when I did this. Question for you though. Let's read this. pH level of water right around 5.3. That looks like, by the way, that means green. Some people don't know how to read a map. Why is it all of a sudden turning like worse as you go to the right?
Is it because it rains more in the east?
It rains more than in the east? Could be. Could be. Rains more actually north up to the left, so I think it's something else. Yes, I have been to New York. Yeah, thank you very much. That is the correct answer. One of them. New York has a whole bunch of cars that don't move very much. A lot of smog. A lot of factories outside of the city. A lot of people. Okay? A lot of cows burping. Look it up. Look it up. Look it up. Bam. Look up cows burping. Effects on the environment. Bam. Important stuff we're learning here. Well, also, too, this is what happens. The jet stream goes this way. So all the pollution that we make here, I mean, goes to them. So you have a lot of the movement this way. Plus you have high industrialization, high factories, high concentration of everything in that area. They get worse rain than we do. Be conscientious of the people in the eastern United States because they're not as beneficial to live in California like that. Okay, same exact stuff we kind of looked at before. So what is acid rain? It's taking CO2 as a gas, hence CO2 is bad, smog, all that stuff. You add that to water, and what happens is the oxygen attaches to this and leaves H positives. H positives are what? What is H plus? What is that? Thank you for the person that's not even in the class for paying attention. No, seriously, thank you. Acid. So, acid, and you have good for us. Not good for us, actually. Okay, right here, that little scale I was talking about bases and acids. Bases have a tendency to be over here. Cations, anions have a tendency to be acidic over here. Atmospheric are in 2 locations, here, and hydrogen's a weird duck, and the noble gases are another weird duck. So make sure you know those areas. That is something we've already learned. You definitely need to know that. Remember these little groups right here. Clear the page. Clear the page. Right here, these things. Let me get my little writer back. They mean something. Take 8 minus that. That's how many ions it has in that column. Deal? Deal. Good for us. So, as an example, if I took oxygen, what number is that right here? What's above oxygen? It's the O for the people who don't know what oxygen stands for. Oh. Look above it. What number is that? Thank you. I have to point at it and still get the results, huh? So we have, I told you to take 8 minus whatever number that is. What number is that? Help me out here with the second. People are still a little confused right now. I think it's C. 2. That's how many ions that group has. That's why 2 ions of hydrogen want to hook up with 1 oxygen. H2. Oh, it's neutral. That's where it comes from. Make sure you know that. Go back and review if you have to. Same exact thing about acid rain. pH level. So again, we have our juices inside of our body. Look at saliva is like right here, more acidic. That was that conversation about the essential question that people are answering. Urine is acidic. Acid rain is acidic. And then blood, all these other cerebral fluids, all these pink, all these really good fluids that are really good for like newborns and for your body. Over here on the base. Again, alkaline to the right. No. We're done. Okay, guys. Is anyone have any questions. If you guys don't have any questions on the internet, go ahead and log off. And you're more than welcome to go put the question inside the essential question answer inside the Dropbox. And let me know again if you have any other questions. Have a good rest of your day.